Okay, so my last tangent and chord video was not working very well, so I created another one. And in this one I plan on doing two problems. Just let's look at the theorems again. The important thing with these theorems is, first of all, if you create a tangent line, so a line that just cuts across a circle on the outside of a circle at one point, it creates a 90-degree angle with this radius. So whatever line you come across here, and it hits this tangent, this becomes a 90-degree angle. So I drew a couple other tangents here. If I draw from the center to this point, that should be 90 degrees here. If I draw a center to this point here, that should be 90 degrees here. So if I draw that, 90 degrees here and 90 degrees here. So that's the first theorem. The second theorem goes by this way. If you have two tangent lines, so if I create a line from E to C and E to D, these touch these points right here and here. These two lines here are equal, and this angle inside here, these two here, if you divide this from the center out to C, these are also equal. So let's call these each x. So they have the same amount. And of course, x plus 90 is equal to this last angle here, or x plus 90 is equal to the same angle. So actually, these two here, let's call them y. Those are also equal. So if you find one, then you can find the whole angle inside here. Okay, so this is two theorems we're going to use, and then I have a nicer picture here from the book. As you can see, x and x, and we can call this small y, small y. So that's our theorem. So let's use these two along with some of the triangle tricks and angle tricks that I gave out in class. So example, let's look at A here. Okay, well, we have 78 degrees up to this point here, and then there's a little bit of angle in here in between the radius and this tangent line. So I know this is 90 degrees, that whole angle. So from O all the way out to here, that line creates a 90-degree angle. So we use one of our tricks, and that is if you have a 90-degree angle and it's split in two, I'll use a different color. If it's split in two, the sum of these two angles in here and in here have to equal to 90. So I can just go to find x equals 90 minus 78. Okay, so this is one of our tricks we have to use in order to do this. And 90 minus 78, you should get 12 degrees. So x is 12 degrees. Okay. To find y, here's another trick that we should be aware of. Well, this triangle inside here is actually an isosceles triangle because these two sides are the same, from O to the outside and O to the outside. So if that's the case, then that means this side here, where x is, and this side here, those angles are equal. So if I add this angle x plus this angle x, I have 12 plus 12 is 24. And the reason why I add these two is because I know that the sum of three angles in this triangle here, from O to the outside back here, has to equal to 180 degrees. So if I go 180 minus 24, that should give me this last angle y. And if you do that, you get 180, 60, 156, which is quite a big angle, but as you can see, this is quite open here. So that is how we get our y angle. So we have our x and we have our y for that one. Okay, so two tricks, 90-degree and the sum of three angles in a triangle, and actually a third trick is the isosceles triangle. Okay, so we've only used a circle theorem here. For B, let's take a look at what this one has. Alright, so we have this angle y, we have 40 degrees, and once again, the first thing I notice is that these two sides are the same, meaning this angle here has to be 40 degrees. So the sum of these three angles in here have to be 180 for this triangle here. So I'm ignoring y for now, I'll use him after, but I can figure out that if I go 180 and I minus 40 degrees, and I subtract another 40 degrees from this angle, then we should get x. And if you do that, you get 100 degrees is equal to x. So we know that this is 100 degrees here. The second thing I notice in this problem is we have a circle theorem, which is this here, which is this one here, the first one. So in the first one, we know if this is 90 degrees, we know already that this angle here, we found out that's 40 degrees. So it's very simple. 40 plus what angle gives 90? Well, the y should just be 50 degrees. And then you've got your angle there. Actually, I'll do one more here. I pressed pause and I added another one, just so we can use this theorem here. So the second theorem. So here we have two tangents. We have an x, and let's take a look. We know that if we were to draw a line from here to here, this would cut this angle perfectly in two, although there's a nice quick way of doing it. Let's see, if you have this angle here, x, alright, wouldn't you say that this angle here should be the same here? Because if this side is the same as this side, from T to P and from T to Q, that's what our theorem says, then this is an isosceles triangle, so it's much easier than trying to cut this in half. In an isosceles triangle, we know that you can go 180 minus 48. Oh, let's try this again. The equation goes like this. The sum of these three angles should equal to 180. So 180 should equal to 48 plus x plus x. So those are x's. Okay, so I create a simple equation. And this is 48 plus 2x. I put the 48 over here on this side, so 180 minus 48. Equals 2x. And then 180 minus 48, so that's 40, 132 equals 2x. And now finally I divide by 2 on both sides to cancel this 2. And I have x is equal to, what is it, 65 in this case. 65. So there's our angle for x using this theorem here.